Australia is a big country. Australia is also a land shaped by wildfire in many places. Join me as we travel around this great country, meeting people and talking with them, and together their stories will come together and help us better explain Australia's complex relationships with wildfire. Welcome to Talking Wildfire Australia, my friends. Hi and welcome. This is Phil Cheney. He is a fire scientist from Australia. Today we're going to talk to Phil about understanding fire in Australia. Phil, can you let us know your thoughts?
Mike, fire in Australia. Fire is a natural phenomenon. It's as natural as the sun and the rain in Australia. All our vegetation has been lived with fire for at least 150 million years. When eucalypts first arrived in Australia after the breakup of Gondwana, charcoal was found alongside the eucalypt seed, and so it's been here forever. It was managed by our Aboriginal Australians, and initially it was every individual who came into Australia had to learn to live with fire. I was in the extraordinarily lucky position that I was a Commonwealth scientist. I had a license to go anywhere in Australia that wanted to understand about fires. And in each place, my knowledge was not only observation in those fires in those areas, but also understanding and looking what the people in those areas that lit them and used them, how they knew about it and what they knew. For example, I had a project to go and look at the burning of sugarcane in North Queensland. At that stage, before harvesting was so efficient that they didn't have to burn, before each harvest, the sugarcane would be burnt off. The fires were generally quite small, and often they were confined within a continuous paddock of sugarcane, separated only by a metre or two where the cane was pushed aside to form a temporary fire break. I couldn't teach the people who burnt cane anything about fires, but they impressed me with what they knew and how much they knew about their own local environment and how that affected the fire behaviour of their sugarcane fires. And what I found really interesting is that people in that area knew what the fires would do in their area, but they were most reluctant to go and tell someone in a different area what the fires would do in their area, because they understood the weather patterns, the climate in their little locality down to a very local level, and that's what determined how the fire spread. And they would safely burn cane in places close to the mountains in North Queensland, where they would delay the burning at night until the katabatic wind coming down off the mountains had stopped and the calm was calm and they knew there weren't going to be any more winds, and just before the humidities got too high they would do their burn. It would be all over in 20 minutes, and extremely precise fire behaviour knowledge in that location. I also had the opportunity to go to every state in Australia, and I carried out fires in different fuel types. And in each case, there was an understanding of the people in those areas about how the fires burnt, what were the dangerous conditions. They couldn't express it mathematically, but they knew in their brain when danger periods were, what to look out for, and that is a key, I believe, to understanding fire behaviour when you're doing research into predicting it, but also how to interpret those research results. If you don't have practically experience with fires in the open, in the bush, in the grasslands, wherever, you'll have extreme difficulty in knowing what to expect and what the fires are going to do. So it does lead into aspects of training of firefighters, leads into aspect of protection of individuals at home. What should they do? Sadly, as the place has become more urbanised, people working in rural areas have been very largely replaced by big, large machines, and so there's much smaller populations. Small fires are either disapproved of or generally banned or under strict restrictions, that people can't light their own fires all the time, and often nor do they want to, because they don't know what's going to happen. And the whole key to understanding fires and training people is getting a familiarity with the process in the field, and then you can interpret the knowledge that is provided to you.
Phil, you said that Australia is a fire-dependent ecosystem. Can you explain more about that?
As natural as the sun and the rain, really. Let's take some examples of some species. The ash forest, the tall ash forests in southern Australia. Tall trees, they grow upwards of 25, 30 metres. The seed in them is the size of a pinhead.
Wow.
It's held in the capsules. When it's released and it falls on the ground, the seed doesn't have enough nutrients to push its new radical down into fine mineral soil if there's a layer of litter on the ground. So an ash forest needs a high intensity fire through it, which often will kill the forest, but it does provide a seed bed. So when the seed falls on it, it falls on mineral soil, ash and mineral soil, and it germinates, and the regeneration of an ash forest is in the thousands of stems per hectare, and it self-thins later on. And other species have different relations. Pretty much all eucalypts will withdraw all the nutrients from their leaves and put it back into their growing system before the leaf is shed. And that's most unlike a lot of European oaks and species like that, because Australia has evolved on an ancient continent. The soils are relatively impoverished except for small areas of new basalt flows, but they are relatively small. And compared to the soils of Europe and America, our soils are very nutrient poor. So our trees have grown up and developed to conserve their nutrients and to take advantage of fire in their life cycles. Pretty much all eucalypts have the capacity to send out epicormic shoots after they're burnt or eaten by koalas, for that matter. You You can prune all the green material off a eucalypt tree and it will sprout quite happily and replace the crown.
What is that, Phil? Is that the actual leaves coming out of the bark or the branches?
Yeah, the eucalypt grows with small buds embedded just under the bark in at the point where the phloem and the bark join. Mm-hmm. And there are small buds there. And when you remove they're held suppressed by hormones coming down the tree while the tree has an active crown in it. But if that is removed, then all these are allowed to sprout out and they go and they replace the whole crown. And that way, many eucalypts can replace their crown within 3 or 4 years after a big fire has been through. And it's very different to, say, the United States, where you go and see a pine forest that was burnt 20 years ago and it's still a mass of dead stags standing up there. Go through a dry eucalypt forest that was burnt 20 years ago and lots of people wouldn't know it had been burnt because the crowns look the same. Admittedly, if they don't know their barks, the barks will probably be a bit blacker than it was before, but here it was. It has had fire and has lived with it all this time.
Phil, do you have any other examples of other species that need fire?
Well, wattles, for example. Wattles have a very hard case seed, and wattles have a relatively short life of maybe 10, 15, 20 years. And they die out naturally if they're not burnt, basically. But it's dropping seed all the time. Every year the wattle drops seed. It's either buried in the soil, other seeds may be picked up by ants and buried under the soil. And all of these need heat as a key factor to germinate them. A wattle has a hard coat seed which needs to be broken before it's germinated, and fire does this. And depending on the depth of the seed is buried, and depending on the amount of litter on the ground, because the amount of heat that penetrates down into the ground is not dependent on the intensity of the fire and how big the flames are. It's dependent on how much fuel is on the ground and how long it persists over that one point. So in an old fuel where seeds have been buried quite well deep, you may well get a different crop of plants growing up, natural plants, than you would if it's only a light fire going through. And everything pretty much in Australia is related in some way to a fire environment. There are fauna that require fire because they require a specific vegetation type, both to create their habitat in which to live and give them protection from other predators, or they need it for food. For example, the Woylie in Western Australia is a small rat kangaroo. It lives on the mycelia of a root-borne fungus on one of the wattles. You can run this past an expert who might give you a more precise answer than me, but generally the wattles die out after about 10 years. And so the food for the Woylie is becoming scarce. So they need a system of burning where the wattles are regenerated and yet there is still enough scrub vegetation to provide protection from predators. And if you are looking at conservation of native species, all of them have some specific relationship to fire. You can't have everything on one spot at the one time. If you want to manage for the environment, for a particular species or a particular animal, you have to understand what its relationship with fire is. Now, when you have large fires like the 2019-2020 fires that burnt out vast areas of the east coast forests of Australia, it was a massive change over a massive area. Suddenly, all the forests were removed. The death toll of native animals is astronomical, and some will be lost because their habitat is not being replaced. And this is where we come to what I've spent a great deal of time of my life, was understanding the conditions to prescribe fires of different intensities in different forest types. MacArthur was an advocate of prescribed burning, and he did it very largely for fire protection. I think now we're developing to a point where we need both. We have to understand what the environment, we've got to make a decision about what environment we want. What animals do we want on this particular area? And if you can make that decision, then you can get a fire prescription which will fit the bill. So, in the Aborigines burnt, I believe, they burnt basically to protect themselves, because they knew if they faced the conditions of 2019-2020, when millions of hectares were continuously burnt, they would starve to death. Because you go into an area like that, and I've been doing it in researching reconstruction of wildfires, and they are barren. There's not a sound. There might be a few raptors. You see them circling above, looking for some carrion of something that has died recently. But that is it. If you prescribe fire and if you burn frequently, then you'll create a mosaic of fuel ages and interfaces between burnt and unburnt areas of different ages. If you advocate a process of total fire protection, you end up with either one type where there has been no fire for 20 years or more, and you have a uniform type of thing that has been protected, or an environment that has been protected, and then that suddenly changes where the whole lot is burnt in one shot. And that's not good for the environment, it's not good for the variety of different species that we need. But if you are burning with the purpose of keeping the fires of low intensity and of a fairly high frequency, then you will create interfaces within the vegetation which will favour different plants, different animals, different birds. With David Packham, David Packham invented the little capsule that has dropped out of aircraft used for aerial mission, potassium permanganate and ethylene glycol. Sorry, my voice is going. Together we went and worked in Western Australia in the mid-60s, and George Peat was another fire research scientist, a colleague of mine. He did the experiments in much the same way as MacArthur. They were field fires, field burns. He developed specific burning guides for the West Australian forests, and that was carried on with about 3 generations of researchers in Western Australia as they extended their knowledge from the Jarrah Forest to the Karri Forest to the woodlands, and finally to the grasslands of central and northern Australia, and spinifex lands. And they're all related to fire, and these men did the same sort of research as I did in practical work, looking at fires on the ground and writing prescriptions based on those observations and measurements. David and I introduced aerial burning in 1966, I think, pretty sure, 66, 67. West of Canberra, up in the hills where the 2003 fires started. A 4,000 hectare block in steep, rugged country. We had a de Havilland Beaver, great big 9-cylinder rotary engine in the front of it. And we burnt 4,000 hectares. The smoke from that fire closed down Canberra Airport for 2 days, but we blamed it on the graziers on the other side. But by and large, in those days, people were used to smoke in the environment because fires were frequent. They were used by the rural people to protect themselves, and that is part of the knowledge that we are finding it difficult to translate to people who have no or very little experience with fires. When we talk about fuel reduction, we really should be talking about a prescribed fire. What is the prescription what do you want? And therefore you say, righto, I want this result. What sort of fire do I need to achieve that result? Now, we initially started off in forestry because we wanted a fire that reduced the amount of fuel on the ground but didn't damage the boles of the tree and leave a fire scar on it, or didn't want to damage the crown and reduce the growth of it. So we set the limit of what we wanted. We wanted a fire where the scorch height was, let's say, only 10 metres high. This meant that we had to determine that we wanted a surface fire that was going to spread and produce a flame height that was no more than 2 metres. And therefore that led us to, righto, to get a fire that is spreading with a flame height of 2 metres and a scorch height of 10 metres, we need a fire that's burning under a certain fuel moisture in the understory fuel and a certain wind speed. And so that's where we decide these are the specific conditions that we're going to burn under. We want to control the fire overnight, so we then work out what sort of burning time have we got. We always believe you shouldn't light a prescribed fire before 1 o'clock in the afternoon, because after 1 o'clock you're pretty sure that the wind speed has settled in for the day, and unless there's a change forecast, which you'd be averse to anyway, the wind then is going to sort of die down and you're starting at the hottest point of your fire cycle for the day. Okay, so that means you've got, let's say, the fires will start self-extinguishing at, let's say, 6 o'clock in the evening. So we have 5 hours of burning. What sort of spacing do we need to set individual ignition points to give us a fire that will spread for 5 hours before it joins up with other fires, and the sort of joining together increases the intensity a little bit, but because it's towards the end of the fire cycle, that won't be hotter than we have prescribed for our prescription on scorch height and flame height, and therefore in reducing the fuel. So for any other objective, you've got to say, what do we want here? We really shouldn't be saying, look, we just want to make a bare waste of burnt ground, and which in too many cases is happening today, where people say, well, burn off the area, and the objective seems to be, we'll get it over as quickly as possible. And so a line of fire is lit, usually on the downside of a hill, it burns the whole lot, it's all over in 3 o'clock, bit of firefighting and the troops go home. That's not a prescribed fire. You've got to have what do you want, and what do you want for the environment if you're going to make a fire prescription. Now, a fire prescription to regenerate a certain species is going to be different. When we harvest mountain ash, for example, we have a fire prescription to burn the slash at an intensity that will be safe and stop the fire that we're burning in the slash spreading into unburnt country, but also removes enough of the litter that the very fine seed from ash can fall down and regenerate the forest. So there's another, quite a different prescription. It also happens to be hazard reduction because we're removing the slash, but the objective of the prescription was to regenerate the forest. And we knew what the seed wanted, so therefore we know what sort of fire that we have to apply to achieve that result. And if we want a diverse environment, and part of our problem in prescribing fires for environmental use is people don't know what they want. And often we don't know enough about the ecology of what's there to say, what does this particular species want that we're looking after? The research may not have been done. The only answer I can give there is if you're burning mildly and frequently, you will create a mosaic of burnt and unburnt areas of different ages, probably up to, well, there will be some areas where fires have been, low intensity fires have been applied frequently, where there'll be little pockets which haven't been burnt for 20 years. They'll just be isolated, little isolated pockets. And there will be other areas that get burnt every year. But there'll be others that have been burnt 2, 3, 4 years between burns. And this creates a diversity within the plant environment that is good for something and give you the most diverse result when you don't know what you want. Miles, miles, miles better than burning the whole lot with a hot wildfire, where you end up basically satisfying nothing but the seed that is going to regenerate en masse from the result of that fire.
Phil, thanks a lot for the talk today. We all really appreciate it. Thank you.
My pleasure.
We're doing this for all of you. If you like what we're doing, please give us a thumbs up, hit the subscribe button, and leave a comment below. See you next time.